Okay, so this is a quick review of something called conservation of momentum. This is one of the sacred laws of physics which can never be broken. However, there is a catch, and I'm going to talk about that catch in a minute. But before that, I'm going to just give you an example of conservation of momentum. So momentum, as we have seen, is given by mass times velocity. And also remember, there was something called conservation of energy, where the total energy initial was equal to total energy final when there was no friction present, right? And that was the catch in conservation of total energy. Here, what you have is this some momentum of the system, and system can comprise of anything you want, so it will mostly depend on the problem. So the system's initial momentum, the total initial momentum, is equal to the final momentum of the system. So if you've got two balls, let's say ball A and ball B, they're traveling like so that there's a possibility that they're going to collide, and that's what exactly happens. And there is a collision here, and then after that they move into separate directions with some other velocities. So let's say the initial velocity of this ball was v sub a and v sub a initial, and that means that just before the collision, and the initial velocity of ball B was v sub b initial. The same way you've got v sub a final and v sub b final. So what the conservation of momentum says is that the initial momentum, that is momentum of ball A initial plus momentum of ball B initial, is equal to momentum of ball A final plus momentum of ball B final. Now if these balls have masses ma and mb, you can further simplify these equations. I said equations because this is a vector equation. That means when I'm writing down these arrows on top, there's just one equation, but if there are two dimensions x and y, you can write the components of momentum, and therefore you can have more than one equation. The same way, if you recall, this was the second law, but in x this was fx equals max, and in y it was fy equals may. So if you write down using the mass and the velocities and use this formula for momentum, what you can write down is mass A times velocity A initial plus mass B times velocity B initial equals mass A times velocity A final plus mass B velocity B final. So this is the equation of conservation of momentum, and you can have more than two objects, and it can be something other than collision too, but the idea remains the same. You write the momentum, the total momentum of something that you call this initial condition, and then finally you write the total momentum, and between both of those conditions the momentum should be the same. The total momentum should be the same. Now about the catch, and the catch is there should not be external force present. Okay, in other words, people say that the system should be isolated. Okay, so if that is true, what that means is that I've decided that there's no outside interference between these two balls coming in and colliding. There's no external force, there's nothing happening. It's just this inside this blue curve is my system, and whatever is happening inside it. Okay, so there's no external force acting on the system, and it is an isolated system. So when that is the case, then the momentum is conserved.